My name is Bruce Webb. I'm with Airbus Helicopters. I'm based in Dallas, Texas. I'm not a podium person. I'm a roamer. So I hope that that does not disturb you. I'd first like to thank EASA for allowing me to be here, specifically Michelle for inviting me. It's a fantastic opportunity to share what developments we have with Airbus. Thomas will speak much more about the actual technology. I will speak more about the human interface. So as we, back, 70 years ago when we started flying helicopters, technology was adapted to the human. Now, in some cases, I think we're seeking what we must do to adapt the human to the technology. Technology is ever increasing, and that's not going to stop. So we'll talk about some fixed-wing accident rates, technology that fixed-wing operators and manufacturers have used, and then we'll roll into the helicopter as well. So when we look at fixed-wing aircraft, and I'm not a fixed-wing person, I only fly helicopters, but fixed-wing aircraft, specifically transport category aircraft, give us a lot of information about accident trends and what can be done to improve safety. You can see it's been an ever-declining or an ever-increasing safe environment in the fixed-wing world. The helicopter world, we're not there yet. I should say the rotorcraft world, perhaps, VTOL. But we have to get there. There's a euphemism. We say often that the most dangerous part of a flight is driving to the airport. And that data is statistically correct when you talk about riding on a transport category aircraft. Unfortunately, it is far from correct when you look at general aviation and charter Part 135 helicopters. We're not there yet. When we look at technology in fixed-wing aircraft, we started, early commercial jets. And in fact, when I look at that, it kind of reminds me of flying old BK-117s, old A3s and A4s. I say old. Maybe people here are still flying those aircraft, but we've evolved beyond that quickly. But when we look at early commercial airliners, they still had a relatively good safety record compared to the rotorcraft world. Why? Why has fixed wing always enjoyed a relatively safer accident rate? And the reality is, it's the environment they operate in, and it is the missions or the jobs with which they do with the aircraft. So I pose to you that when you fly on a commercial airplane, what it does is it taxis out from a ramp on a taxiway which is deemed to be safe by the authorities. Right? It's a movement area. So you know as the pilot of the aircraft that the surface is safe, what load it will bear, the dimensions that are safe to taxi down that. You go to a runway, you go to the threshold of the runway, you know the precise length of the field or that runway, you've calculated your balanced field length, you know the exact mass of the aircraft, you know the winds, the temperature, the humidity, all that information is provided to you. You advance the fuel flow control levers, you depart, you immediately are in controlled airspace, you fly wherever it is that you fly in controlled airspace, it's all been terped out, it's deemed safe, and you arrive at a location, another airport, and it's the same for the return. You're never in a condition where you as the pilot have to determine virtually everything. That's vastly different than the helicopter world. In the helicopter world, many of us, we take off from a location that may be known to us, but their destination is often unknown. When ADAC lands a ship on the Autobahn here, I doubt that it's the exact location that they've landed previously. Who determines what the winds are? The pilot, right? Who deems it to be safe for landing? The pilot. And Not only that, it's the flights that we do. I hesitate to use the word missions because that has a connotation that I think we need to step away from. Because missions imply something that is perhaps greater than really we should contemplate. There's something called the ideomotor effect, and what it really means is words matter. So that's why the FAA removed emergency from HAA, helicopter air ambulance. It's no longer an emergency. It's a flight. But think about what many helicopters do. So we are working in the emergency medical field. We're working in firefighting. We're working in law enforcement. We're doing missions. We're completing missions, flights, that are critical, important, and by their nature, timely. How many aircraft are leaving Cologne, Berlin, Munich, Frankfurt today on such a mission, on such a flight? None. None. The 777 that's going to take me home next Sunday or Saturday, the biggest emergency on the ship will likely be they've run out of champagne in business class. That'll be the emergency. So we have to keep that in mind as we progress through technology. So we went from the basic aircraft where the pilots were hand flying the ship to automated flight. But still, and for those of you in the room who are, I used to think that I was young, but I've learned that I'm not. When we first flew aircraft with autopilots, automatic flight control systems, the analog systems, there's a reason the Victor Airways are 4 nautical miles wide, because you needed 4 nautical miles because they drove down the Victor Airway like a homesick angel. They just kind of wandered down it. Not today. With RNP 0.3.1, I mean, we're going down those airways like you're on rails. In fact, I and other pilots in this room, I bet, have adopted this. If I'm going down a Victor Airway, I use cross-track and I set myself off by 0.2 nautical miles to the right of the airway. Because if everyone is that precise, we didn't have to worry about that when precision wasn't this good. Today it is. Funding went to glass cockpits, FMS flight management systems, again through GPS, through the technology we have today. If you're 10 feet from your desired location, you're off flight path. And finally now, 4, fly-by-wire. Of course, fly-by-wire started with the Concorde. The Concorde was the first commercial aircraft with fly-by-wire. So it's been around a while, but in common use, it has not been around a long time. So, but with this new technology, we're stumbling into problems that we never believed existed. There was a consequence to the technology. The unintended consequence of all this fantastic technology is it's easy for a pilot to lose their skill to manually fly the aircraft. Quite honestly, to recognize the need to manually fly the aircraft, and then the ability to do it. And again, I think we're all aware of some recent accidents, and I'm not talking about just in the past 12 months, but perhaps in the past 5 years, where there have been some horrific accidents because, quite honestly, the flight crews were either incapable of handling the machine or didn't have the knowledge to handle the machine. So long ago and far away, when you flew that aircraft in position 1, a VOR was a VOR, an NDB was an NDB. Today, every receiver is a little different. And if you don't know precisely how to use it, and you find yourself in an emergency situation, you're lost. Humans are like computers, or perhaps we built computers to mimic us. Now, I'll come back to that. So when you look at the fatal accident rate in fixed wing, as we come down, you'll see from the 3rd generation to the 4th generation, that's actually a 50% increase or a 50% improvement in the accident rate from 0.08 to 0.16 to 0.08. That's significant, and that is what we're trying to do in our industry today, is to reduce accidents by 50%. Now, the reality is we're not at 0.18, unfortunately, but we have to strive to get there. Oftentimes, people will say when we're giving presentations, it's unreasonable to expect us to have no accidents. We may never get there, but I don't think it's unreasonable to plan for that, shoot for that, expect that. Let's just imagine, how many deaths are acceptable in our business? Because if you believe one death is acceptable, raise your hand if you want to be that person. Because I don't want to be that person. And it's easy to say, well, 4 is okay. Okay, that's the front row here. You're done. I don't think you would accept that. We have to seek 0 accidents, 0 fatalities. Everyone should have a card in front of you, and this is audience participation time. I want to demonstrate, I want you to help me demonstrate to you that we have a physical impediment and an intellectual impediment to our visual system, and we have to understand this when we design aircraft. So, if you will all pick up the card in your right hand, please. You don't have one. Mode? They don't have a card. Do you have? You're okay. You'll make the video more attractive. Thank you. Okay. Mode was telling me that the cameraman would make me look attractive. I said, I don't know what kind of filter he has on that camera, but if he can make me attractive, that's great. So if you have this, and by the way, Airbus is written across the top. Is that an advertisement for Airbus? No. When I first did this presentation 5 or 6 years ago, I didn't put anything across the top. But what I found was everyone would not orient it correctly. But the mere fact I placed a word across the top, I could have put rhombocaza dodecahedron across the top, and you would orient it correctly. Because that's understanding human behavior. So if you will hold the card in your right hand, extend it arm's length in front of you, hold your hand over your left eye, focus only on the dot. And sir, if you don't cover an eye, it doesn't work. You have to cover an eye, card in front of you, bring the card towards your nose slowly, and what you will notice is the dot will disappear. If you're focusing on the cross, the dot will disappear slowly to your face. And if you continue to bring it to your face, it will reappear. Anyone who cannot make it do this, we'll do a remedial training. You maybe had a mimosa for breakfast. But I promise you, you all have a blind spot. And we could reverse it and do it with the left eye as well. You have a blind spot. Why? Well, it's because where your retina attaches to your optic nerve, you can't make it do it. Most people don't hold the card directly in front of their face. And you should be focusing on the dot cross. You can see this still. Slowly bring it to your face. Slowly. Right in there, the dot has disappeared. Where our retina attaches to our optic nerve, there are no rods, no cones, no photoreceptors. You are blind. Okay? It is certain. But here's my question. What did you see as you brought it? The dot disappears, yes? But did you see nothing when the dot disappears? I believe you still saw white. Who here didn't see white when the dot disappeared? Why? Without glasses. Why? You can't see. You're blind. It's physically impossible to see anything. But yet you did. You saw white. Your brain is a 3.5-pound piece of meat that's tangible. You can touch it. 80 billion neurons. 100 trillion connections. It is the most complex machine in the world. Your mind, your brain, not mine, consumes 12.6 watts of energy to operate. IBM built a computer called Big Blue to play Jeopardy. You know, Alex Trebek, Jeopardy? 76,000 watts of energy to beat a 12.6 watt human. We are a marvel. That's your brain. But your brain couldn't see the dot. What did your mind do? You have a brain, that's hardware, like the hardware of your hard drive, your hardware of your computer. Your mind is the software. So when the brain can't detect something, but the mind says, well, I know everything around it's white, ergo, it must be white where I can't see. That's a little frightening. And there are people in this room saying, Bruce, that's a wonderful parlor trick. I did that in kindergarten. Fantastic. So we're going to play a video, not yet, but we're going to play a video. And what I'm going to ask everyone to do is you're going to focus on a central flashing green dot. There's a central flashing green dot. Just concentrate on the green dot. Don't look at anything but the green dot. There are 3 yellow dots in the periphery, and you will notice that they intermittently disappear. So let's go ahead and play the video and see if you notice the dots disappear. So focus only on the central flashing green dot. Do you see it? Intermittently, and by the way, the closer you are to the screen, the more apparent it is. The further away, the less. Let's go ahead and stop it there. We'll talk about it, and then we're going to come back. So you can stop the motion. What happens here is your eyes are being drawn through a blind spot through the card in the back. Can you go to the beginning and play it again? So now don't look at the flashing green dot. Forget the flashing green dot. Just look at the 3 yellow dots and tell me how often they actually disappear. And I'm certain you're aware, they never disappear. They never disappear. As your eyes are drawn through their individual blind spots, sometimes the blind spots line up. And using binocular vision, 2 eyes, you can't see the dots. We know this. So when we're flying and a pilot says, I didn't see something, I used to think, cavalierly, that, the pilot's full of beans. The pilot is not telling me the truth. Sometimes the pilot doesn't see. They don't. And when you're under higher cognitive load, the worse our abilities become. We'll come back to that. That's why training is so important. So let's look at helicopters. Back in the day, early helicopters, and some of you flew 47s. That's a J model cockpit, actually. By the way, I was doing a presentation a few years ago, and I came to the understanding that I am old, and here's what. Well, I'm old, or our industry is young. Like many people in this room, I've been flying helicopters 38 years now. There have only been commercially certified helicopters in the United States for 72 years. The Bell 47 was certified in June of 46. I've been flying helicopters half as long as there have been helicopters. We're a young industry, and look at the evolution we've already taken, right? We are moving rapidly. Technology is moving rapidly. How about the human? How much different is a pilot, the physical person, in 1946 than from today? We are fighting 80,000 years of DNA, folks. None of us in this room are built to fly. We weren't built to fly 80,000 years ago, and we're still not built to fly. But we're clever. We're clever. We're Homo sapiens. We're the last of the sapiens. You could be proud. Give yourselves a round of applause. We're the last. Homo sapiens. Neanderthals didn't make it. Homo erectus didn't make it. It's us, folks. But we have limitations. We just don't understand our limitations. If I would ask people here to come out, if I said, this is a joke, if I said I have a brand new H-160 outside and I'm going to give it to the person who can run a 4-minute mile right now, I'd bet a fair bit of money, there's not a person in this room who can go outside right now and run a 4-minute mile. And most of us know this. But if I were to ask you to do a cognitive test, and I don't have time to do it today, but it's called +1, you would all believe you could do it, but you can't, because we don't understand our intellectual limitations. We think we are much more capable than we are. And as humans, specifically in a cockpit, but working on aircraft, it doesn't matter, as a human, our mind deceives us. Our mind deceives us. If you ask a pilot, any pilot, are you okay to fly right now? If you say, listen, we've got an emergency, some emergency. We need pilots right now. Can you go? How many pilots say, nope, I'm just too tired to go? None, not one. You could have been up all night, but because there's a mission to be flown, you say, oh, I can do it. No. Oftentimes we're not capable, but our mind deceives us. Just like it does if you're at the Chris Crindle Mart and you have 8 glue vines, it may be difficult to walk home. But if you ask the person who's had 8 glue vines, are you okay? They're going to go, yeah, I'm okay. No, you're not. You're inebriated. So we've gone through these iterations, and finally we're at the 4th. We're at the latest, and it is fantastically capable, but it's still being operated by the original human. We're no smarter today than we were 2,000 years ago. We have more information. In fact, it may be the case that we have today, everyone in this room has a smartphone, promise you. Probably everyone in Cologne has a smartphone. We have access to more technology than ever in the course of human history. However, the curve for knowledge may be decreasing on the same scale. We have lots of information, not the knowledge to use it. And we find that out, unfortunately, in aircraft accidents. When we look at the fatal accident rate, now, the last slide, and Tony with Bell, his curve at the end took a different direction. There are prognosticators. We don't know where that curve's going at the end. Some say it's going to go up, some say it's going to go down. Certainly we want it to go down. We want it to go down. We're working to bring it down. Where it goes, I don't know, but I do know the trend is fairly flat with some excursions, especially 2013. Our trend is flat. We must stop that. It's incumbent upon us to change that, not others. I was at a meeting in D.C. a year ago, and I wanted to jump out of my seat because people were saying, we have to touch them. They have to be better. Those people, it's them, those. No, it's us. Us. We're in this boat together. It's our responsibility. When we look at accident statistics, and I put this up here, not for data, but to talk about how important it is to understand we need to be looking at incidents, not accidents. Once the accidents occurred, the cow's kind of out the gate. It's too late to help those people. And that's not to say we don't investigate accidents, but we have to look at what we know is behavior that leads to accidents. Simulators are fantastic places to learn. They're also fantastic places to do research, to study human behavior. You can put a IFR helicopter pilot in a VFR helicopter, put them in a cloud, and they'll be fine for a few moments. And they may be fine for longer than that. And if they're really, really good, all you have to do is bring the ceiling up a little bit, let them see the surface. Once you see them look down at the surface, because when they look down, bring the clouds right back down, now they're back in the soup. They bring their head back. And you know what? Our vestibular system's no different today than it was 80,000 years ago. You will get the leans. Anyone who's flown IFR and something has gotten the leans. It's incredibly difficult to overcome. We just don't choose to overcome it. We have to have systems. So at Airbus now, we have a recovery button. You can double-click the button, stabilizes everything, engages 4 axes, takes over the helicopter. Because we know you can't. It isn't that you don't want to. You can't. If you've flown our products, you're familiar with the central image especially, the FLI, First Limit Indicator. So if you look on the left screen, that's probably an old Bocow, B105, but it could be any manufacturer's helicopter. It's the old analog technology. And when you look at that image, imagine as a pilot, you're coming out of a hover hole at 2 a.m. at Butte, Montana, and you're on your N1 limit, you're on your T4 limit, and you're on your torque limit, all within a couple of % of one another. You're going to hit the tree ahead of you, so you add additional power to miss the tree. Did you over-torque it, temp it, or speed it? And the answer is you don't know. Now, unfortunately, human behavior, what pilots did back in the day, they'd fly it back to base, get the mechanic on the phone, go through the maintenance manual, and they would find out that if they over-torqued it to 110% for less than 5 seconds, no foul. So guess what the entry was in the book? Below 110, below 5 seconds, no foul. That's not the right way. That's not the correct way. So we've devised a way to know the first limit because subsequent limits don't matter. If you don't exceed your first limit, who cares what your second limit is? That technology is phenomenal. We've morphed it from the central screen image to the screen on the right, the image on the right, where actually now it's in the primary flight display. It used to be you had to look at a separate instrument to see it. Now we embed it in the primary field of view. Why do we do that? We don't do it to save money on screens. In fact, there's an argument that more screens are better than few screens because if you only have 1 or 2 screens and it fails, you got to get a whole new screen. If you've got 5 screens and one fails, they can reconfigure. That's a different argument. But the reality is this. We put it in one central location because we want to reduce load, the cognitive strain on the human. We want to reduce the cognitive strain on the human. And by the way, humans have limits too. You have a first limit. If I ask you to go run a 4-minute mile, let me tell you, you're going to find out what your running limit is pretty quickly. And it's probably not your legs or your core, right? It's interesting, the first limit often in our lives is our minds. We choose to quit. But when you are over the limit, we know on an aircraft what the limits are. We put them in a flight manual. What's your individual limit? God didn't give you a flight manual that says, well, Bruce, you should have 7.3 hours of rest every day and consume exactly 1,900 calories, no more than 150 carbs, no more than 24 grams of sugar. It doesn't exist. And when you are task saturated as a pilot, well, let me back up. What happens if you tried to run your current software, the current software right now, on your freaking phone, and you tried to run that same technology on the computer you owned 30 years ago? What would the computer do? If it could run the technology, it would lock up, right? It would lock up. What do you think human beings do? What do you think a human does when they're overtasked, they're task saturated? What does a human mind do? It shuts down. You shut down. You stop thinking. And actually, the fascinating thing is, it's why we train, you're going to revert to what you're trained to do. Not what you think you're capable of doing, but what you're in fact capable of doing repetitively, comfortably. That is why I believe we have so many IFR pilots getting into an inadvertent meteorological condition, a degraded visual environment, and they will spend every ounce of their effort to stay VMC because that's where they're comfortable. They're not comfortable IMC. Even though they're technically capable, they're not comfortable, so they won't do it, and they crash. And then we all say, geez, how could that 10,000-hour pilot make that mistake? The 10,000-hour pilot's been doing that his whole career, her whole career. It just caught up to them. It caught them out this time. There's not a pilot in this room that has not flown in a condition they would be pleased to announce to the authorities. Not if you've made your living flying helicopters, but we have to get smarter. And that's what we're doing with technology. We understand, the engineers understand, we have to match the technology to the human's ability to use it. If we exceed their ability to use it, they won't, and then it's useless. Yeah, I'm actually on time. I'm never on time, by the way. So I'm going to conclude with this so I remain on time. Training. Training, training, training. It's fascinating to me. Well, that's not fascinating. It's disturbing to me that as an industry, and I'm not talking just about helicopters, I'm talking about the aviation community, we worry too much about credits and not enough about training. If you fly a Garmin GPS, and everyone in this room has flown one, and if you haven't flown one, you've driven one because they're in your cars, Garmin puts out a simulator, a training simulator. You download it, you can load approaches in it, you can fly routes. It is fantastic. If you download the Garmin 750 simulator and learn to use just that simulator, your ability to manipulate and fly the ship you're flying will be greatly enhanced. What credit does EASA give you for that training, or the FAA? Not 1 second. Why do you care? I know the answer to that. We have to stop caring about that. Train. If there's good technology that will help you be a better pilot, a safer pilot, a more productive pilot, and you choose to ignore it, shame on you. We're to be professional pilots. That doesn't mean, I don't get paid for everything that I do. I don't say, well, if you don't pay me extra, I'm not doing that. Why do we do that in the training environment? So, step back, evaluate what you're doing, determine what the importance is of it, and then execute. Execute. There's thousands of training aids out there. Most of them give you no credit. So be it. Get the training, be safer, use the technology, understand it, and use it. If you don't understand it, you won't use it. So that's all that I have. Thomas will expand far greater on all the technology, but that's my take on the human interface. So that's all that I have. I thank you for your attention, and again, my pleasure to be here.